So welcome everyone in this amazing video. Today we are going to discuss weighted binary codes. In the previous video we have discussed all the classification of the binary codes, where we have seen 6 different categories in which all the binary codes can be categorized. Today we are going to understand the first category, and that is weighted binary codes. Let's first understand what is the meaning of these weighted binary codes. Some of the introduction I have also given you in the previous video. Still I will be giving you the full introduction over here, full understanding I am giving you over here. So please understand. So in the weighted binary codes, each and every bit position, right? Each and every bit position will have a specific weight, and that weight will be associated with their positional value. Okay. First I will read all the sentence, then I will explain you the meaning of these sentences. Now these positional weights are defined in terms of power of 2. The value of each bit depends on its position in the binary code, and thus the rightmost bit has the least weight and the leftmost bit has the highest weight. So I'll just give you one example, and with that I will try to explain what is the meaning of all these 4 sentences. So if you remember, like the first sentence, it says that each and every bit position has a specific weight. So if I'm writing 1 0 1, right, and this is a binary, right? Binary we have seen in the first and second video in this playlist. So if you see, this has a weight 1, this has weight 2 to the power 1, and this has weight 2 to the power 2. So here also, if you see guys, here each and every digit holds a specific weight, and that weight is associated with their positional value. Second point says that weight are in terms of power of 2. So here if you understand, the first position is having weight that is 2 to the power 0. The second digit has the weight 2 to the power 1. Third digit has the weight 2 to the power 2. So as you can understand, each and every positional weights are in terms of power of 2, and the value of each bit depends on their position, right? Obviously, if there is a third position bit, then the weight is 2 to the power 2. That means it is having the weight that is equal to 4. Now if we read the last sentence, that is a very important statement. So over here it is saying that the rightmost bit has the least weight, right? So here is our rightmost bit, and this will have least weight, and that is also what we call LSB, that is the least significant bit. Okay, because its value is very less in terms of all the other positional bits. Similarly, the leftmost bit will have highest value, and that is what we call MSB. Okay, so this is all about the weighted binary code. Now let's see more. So weighted codes may be either positively weighted or they can also be negatively weighted, and all the positively weighted codes, right, will have positive weights only, and there are total 17 positively weighted codes. Okay, a few examples that we are going to take is 8421 code, that is also known as the BCD code. Then we have 2421 code, 5211 code, 3321 code, 4311 code. Now in all of these codes, apart from this 8421 code, if you see all the other types, right, then when you do the total of their position weights, likewise here 2 plus 4 plus 2 plus 1, so it is going to be 9. So all these binary codes, their totals should not be less than 9. That is the important catch over here that you need to remember. So now let's understand the first type of code, that is 8421 code. That is simply BCD code. That is what we call BCD code. Okay, BCD means binary coded decimal. Okay, binary coded decimal. See, BCD is kind of a binary only, but it works different. It is not exactly binary. From 0 to 9, BCD is equal to binary, but the change will come from 10. So if I write what is the binary of 10, binary of 10 is 1010, right? But the BCD of 10 is different. BCD of 10 is basically 10000. So how is this working? So basically in BCD, what we need to do is each and every digit will get 4-bit binary separately. So simply, if I am having 1 and 0, so 1 I will represent with 4 binaries. So what is the binary of 1? Binary of 1 is 0001, and For 0 also I need to write 4 bit equivalent binary. So what is the binary of 0? That is going to be 0000, and that is how your BCD is 10000. So this is the BCD. Now here if you see 8421 code that is we are having, right? That is simply meaning that when we are having any four digits, right, like this, so the rightmost or the MSB will hold the weight that is equal to 4, then this position bit will hold the weight 4, this position bit will hold the weight 2, and the last bit will hold the weight 1. Okay, so this is how it is working. Now I'll give you some more examples so that you guys understand that how it is exactly working. So for example, I'm taking 7. Okay, if I want to have 7, and what I can do, I have to add 4 plus 2 plus 1, right? I don't have to add 8. So this is what basically I need to do. For 8 I will represent it by 0, 4 I need to add, so I will write 1, 2 also I need, and 1 also I need. So my 8421 code for 7 is basically 0111. It is simply the binary that we have understood in the previous lectures, right? One more example, for 6 we want to add 4 plus 2, right? 1 we don't want to add, and 8 also we don't want to add. So this is going to be 0, this is 1, this is 1, and this is 0, right? So it is going to be 0110. Similarly, if we want to write 76, so what we need to do, for 7 also we need to write 4 equivalent binary code, that is 0111, and for 6 it is going to be 0110. So this is your 8421, or what we call BCD code. I hope guys you understood with this example what actually the meaning of BCD code and 8421 code. Now let's see the second type of code, that is 2421 code. So here the 4 different digits in the binary, like they are going to hold the weight 2421. So if I'm writing 1111, so MSB will hold the weight 2, LSB will hold the weight 1, this bit is going to hold the weight 4, this bit going to hold the weight 2. So for an example, if I want 6, right, so what I can do, so here I have 2421, which digits I add so that I'll get 6. So here we have these 2 plus 4, that is also 6. Similarly, this 4 plus 2, that is also 6. But here what we are doing is the binary, so we need to create the code that is quite different from the actual binary. So what I will do is I will add the first 2, so 1100, that is going to be my 6, okay, as per the 2421 code. Similarly, if I want to make the code for 5, so for 5 what I can do, so there are two options. I can add this 4 plus 1, that is going to be 5, but that will be 101, that is quite similar to binary. So what other thing that I can do, I can add this 2 plus 2 plus 1, so 1011, that is the code for 5 in 2421 coding system. Next example, we can take 5211. So in 5211, if I am writing these 4 digits, so the MSB will hold the weight 5, LSB will hold the weight 1, this bit is going to hold the weight 2, this bit is going to hold the weight 1, right? So let's take few examples. Let's say we want to create 6. So for 6, what we can do is we can add this 5 and this 1, that is going to give us 6. So our code is going to be 1010. Okay, similarly, let's say we want to create 3. So for 3, what we can do is we can add these two number, so that is 0110, that is going to give us 3, right? So this is how 5211 code works. Basically, you need to think of, here there are multiple numbers are possible. Let's say for 3 you can add these 2, similarly you can add these 2 plus this one also. So here the programmer is going to decide that what is going to be their coding system, and that will also be received by the receiver, that how they have to decode it, because here this is the game, because that is how you are making the things different for the person who is actually capturing your message in between. Otherwise, if we simply applies 5211 code, he can easily decode your system, right? So that is the one of the thing that is making it difficult for the person who is taking your messages, right? Now let's see the next one, that is negatively weighted coding, right? So here we have a different type of negative weighted code in which some of the digit will hold the negative weight, right? One of the example is 642 minus 3 code, 631 minus 1 code, 64 minus 2 minus 1 code, and 74 minus 2 minus 1 code. These are some of the examples of that. So here if you see, when we take 642 minus 3, right, and so 4 different digits are there, so MSB is having the weight 6 and LSB is having the weight -3, and the between these two digits it is having 4 and it is having 2, right? Let's take the examples of 642 3 quarter. Let's say you want to make 1. Okay, so for 1 what you can do is, we have 4, right? If I write 642 3, so 4 minus 3 will give me 1, so 0101, that is going to be my 642 3 code. Similarly for 2, when we have 642 3, so this is 4 and sorry, directly we can use this 2, right? So 0010, that is the code. And let's say for 3, so for 3 what you can do, so you can have 6 minus 3, that will give you 3, so 1001. So this is the coding for 642 3. So that is all about the weighted codes. Here I have taken the examples of 3-4 different coding system. I hope that you get the fundamental clear that what actually you need to do when you read the name, whether it is 8421. So you simply see that by adding what different numbers you will get your decimal. So that is the trick that you need to follow for all the types of coding system. At the end I have prepared this summary table. So in this summary table for 2421, 5211, 642 3, as well as 84 2 1, I have written the code from 0 to 9. You guys can take a screenshot and you can do the analysis on these different codes. So with this I am ending this video. And at the end I want to request you that if you are liking these videos, if you are liking this type of content, then please subscribe this channel, so whenever I post any new video you get the notification and you get the learning. With that, let's end this video. I'll meet you in the next video. Thank you very much.